Okay, so our first one is composition L, and it is pretty low on sodium carbonate and a little bit high on calcium. I'm expecting those two to kind of cancel each other out, but low sodium, slightly high calcium glass. We've also got some chrome and copper. That's an interesting combination. We actually have a whole family of those. So hopefully that's pretty because we have about 4. They're related. So this is a chrome copper glass. So what I'm going to do is I'm going to be pouring right down this line, and I'll probably do it in 3 rows of 4. So that way we'll have plenty of real estate there to work with. All right, so here comes our first glass. Glass 9L. Right? So get it even closer to the surface, so the inner coat is kind of right against the glass. So definitely the low sodium is made of more viscous glass. So now heat that string so that it separates nicely, and then heat the surface of that little tail. Heat that tail that came off the side. Over on this side. Okay, that's probably pretty good. Now you can move in and stamp the lower edge of that. That'll work.
I don't know if I can see it.
It'll work as long as I can decipher it. So normally what you want to do is square them off so that they're flat. And then you just kind of press them both in. It's melting into my shoe there. Let's check the extra glass in. Yeah, the interesting thing about copper glass is that the copper is in that noble metal family, and so it's easily reduced. And so what we'll see is that the inside of that flame has some completely combusted fuel, so it makes carbon monoxide inside the middle of the flame. And we know from lecture, carbon monoxide is a common reducing agent, and so it's able, if the flame is held close to the glass, it is able to reduce the copper in the surface. Let me borrow this a second. If you look at this shelf of glass on the crucible, it's not copper mirror yet. So I'm going to flame polish that, and what we should see is I can flash that to a copper mirror by heating it with the inside of the flame here. So I'll do just this one. We'll have other copper compositions, and you can see the effect of not doing this. So once that cools, it should be nice and shiny with a copper layer on the surface of that glass, but I just reduced the skin of copper that was coloring it to a copper mirror. So that went fine. So the next one is M9M. This is a straight down the line viscosity, 90, 50, 25. 90 of the silica, 50 sodium carbonate, 25 calcium carbonate. This one is similar in that it's chrome plus copper plus 1 gram of manganese. I had that one before, so we should be adding some purple color to it as well. It'll probably look the same until we can get some light behind it and look through the glass, and then we'll be able to detect some different colors. So, all right, so M, I'm pulling from the left. Go ahead. You can open a little bit quicker to center, but that's still way down when you go through vertical. You can see the more typical flux load there is making it easier to pour compared to that previous one. Now just really heat the center of that to get that to melt down into the disc. That's fine. So you can go ahead and squeeze the outer edge. Normally what you'll want to do is come in from the side that doesn't put you over the previous disc and try to find the distance of least encroachment so that you don't get the heat, because there's a ton of radiant heat that comes off of this. That's an unusual color. As the glass cools, the color changes. It's called the strike temperature. Chromium starts off brown and then strikes green at about 500 or 600 degrees Celsius. So as it cools, the fiberglass will change color. This looks like a really dark purplish color to me right now. So we'll see what happens later. You're also going to hear a chorus of glass crazing soon. What happens is the ceramic shrinks at a different rate than the glass. And as a result, it causes cracks that pop and crack inside of that layer of glass that's still adhered to the crucible. So soon you'll hear that little sound times 20 in intensity. So, okay, next up is N, which is yet another chrome copper glass. This one is quite high on copper, and so that should be related to this family. It's kind of neat. We have sort of a series of chrome doped glass with copper. So this is 9N, going from the right. Okay. Okay, you can close here a little bit closer still. Try to really heat up that. There you go. See it sink in? That's what you're after. So go a little bit closer to the edge of the disc this time. All right, that'll work. So again, sometimes this is unattached. Well, the evaporation inside the tank leads to a lot of heat. One word of caution: resist the urge to grab these pieces of fiberglass up here. It's different than fiberglass insulation. This stuff is kind of like these needles just shatter and just before you know it, poke into your finger. It has happened, not to me, but to a different professor in the past. Got stuck, I think, through their glove with fiberglass. So I try as best I can to minimize that fiberglass formation. Okay, next up is 9O, which is a cobalt copper glass. Blue on top of blue. Bold move. Bold move. So we'll pour that one right here. Is that going to be enough? You have enough clearance to get around those without hitting them? Okay. So we'll go for right there. Yeah, sounds good. Get a little bit closer. There you go. neat so I can file off that last little bit. Definitely looks like blue glass. You can tell on that fiberglass on the side there. This metal actually heats up about like a hot griddle. You could probably cook pancakes and eggs on this by the time we're done with little pieces of glass in it. So probably not the best idea. But yeah, so far they all look very similar from the top because of the copper. Once we get it on the light table, we'll be able to see a lot more of the color depth on the inside. So we'll start a new row here. So next up is P. That is a manganese glass. So medium high load manganese purple. So 9P is going from the left. Sure left. All right. So I haven't been properly calling the viscosity differences. So O and T. P was a little bit low on sodium, a little high on calcium, so that fairly evenly cancels out, but we will take some diameter measurements and try to assess the viscosity of the pour. Okay, so next up we have Q, 9Q, and this is a copper iron glass. Copper iron. So, on the right. Just gauging off of this, it looks like a light bluish green color. Not supposed to touch. What was fishing out? So you can certainly hear the phrasing happening over here now. And this was kind of neat. It has just a little bit of a copper flake that got mixed in on top kind of looks like one of those Firebird insignias you put on Trans Am or something. Back in the good old days. It's kind of neat. There's something like that before. Next up is R. Right? So this is 90 silica, 60 sodium carbonate, 60 really high on sodium carbonate, and 30 on calcium carbonate. This is going to really come flying out of that crucible. So this is high sodium, high calcium flux. So I'm expecting a larger than normal disc, not like a huge pancake, but watch how easily this one pours, assuming science is true. And put that one right there. Hopefully it's true. So this is from the right center. Those are. Yes, and the color this time is a copper manganese. So kind of a blue tilted towards purple. That should be neat. So, okay, kind of pulling from. Let's go. Get that bubble, make it pop there, you know. And so when we're done, work that bubble area as well to get that to pull properly. Definitely a lower viscosity on that glass. So science is true. We proved it again. Always glad when that works out. You know, it's not like no pressure science, but so lots of copper. Okay, next up is S. And S is slightly low sodium, middle of the road calcium, and it's an iron glass. So we're expecting this one to be kind of a greenish glass with no copper mirror for almost the first time. So it should be distinctly smaller and a little more viscous than the last pour. So we'll put that one right there. And pulling from the left. Go ahead. And really hit that. There you go. This one separate. So this is especially bad lab to be wearing flip-flops, so hopefully nobody's wearing flip-flops. I think I mentioned that I have seen flip-flops at a Foundry tour once. Sad day. But we all survived. So. 4 more. So this one starts off looking kind of brown, but then the iron, but then tilts towards kind of a greenish amber color somewhere in there. So next up we have composition T, right? T is a low sodium, low calcium flux. So this is low flux. So it's going to be a small diameter again, presumably. And it has a copper nickel. So it's smoky blue this time. Smoky blue. Copper nickel. Smoky blue. And you're right. And you'll get the pleasure of seeing my gloves smoking. These next three. You have to go all the way in the mouth of the lion there to pull out the crucibles. Somebody right here. So please try not to impale yourself on that artwork right there. That's very beautiful. Lots of copper. Yeah, definitely a lot smaller diameter. So we'll be able to assess that once they cool enough to get the ruler measurements. So three more. We've got 9U. And this is just a touch high on calcium. But otherwise, what I call the baseline composition, so average diameter. And this is a good pairing with that last one. So this one has half the load of copper and way higher, right? So I put in 0.9. So this is like 10 times the normal amount of nickel. That's a lot of nickel. I don't know if that's a decimal error or not. So this might be black glass. Well, no, it's 0.9. Yeah. So this is like 10 times. So I have no idea. This might make the room implode. I've never done this experiment before. So we'll put that there. My guess is going to be almost black glass. Yeah. So I should have it. We should have some kind of a raffle to be ready. So I'm pulling off the center. Okay. Here we go. Crazy nickel blocks. Room hasn't imploded yet. That's good. Pull this out. I'm not able to see the color. I guess so far it doesn't look that dramatically different. We'll see what happens after the. I just made fiberglass against my photojournal. My guess is that once the color strikes, the nickel I think strikes lower, meaning it has to cool down for the color really takes hold. My guess is by the time we're done, we should be able to notice 10 times the normal amount. It's like trying to work with giant thumbs, no other fingers. So there we go. Now look at the way that color on the edge of the crucible is changing as it cools. They actually started pretty close to each other, but now as it's cooling, look at the nickel finally resting into its what are called coordination sites with oxygen. It gets tilting from blue to super duper dark. So there we go. Black glass, I think is where we're headed there. You couldn't tell it until it got significantly cooler. So that's great. Two more, B and W. So B, it's a carb. So B, 90, 40, 25. So slightly low on sodium, average on calcium. So this is a low flux. We've got half chromium, half copper. Seen it before. So more viscous, right there. Okay, go ahead. So really concentrate some heat on that to get it pulled in. Okay, I think it looks good. Except to leave a little ripple in the top. Okay. So far nobody's burned, right? One more to go. I had to ask. Got skin right in my face. It tried to get me. I think the piece is down in my shirt. Hopefully I'm not burning my shirt. We'll see. I don't feel any pain, so I think we're okay. But that piece of glass is somewhere. It's a little one. One more. Put it right there. So this is W. And it looks like a slightly high calcium, medium, or average sodium glass. And this one is chrome iron again. I guess we haven't had chrome iron yet. We had copper iron, not chrome iron. So, okay. Good. Okay, it's a successful run there. So I don't think any of these are going to break. Some of the compositions have problems or just seem like they're going to break, and I cover them with a beaker. You can usually tell if there's defects that are going to make it shatter. These all look pretty clean, so It's going to take at least a half hour for those to cool. So what we'll do is I'm going to show a couple different example videos of about 10 minutes worth of different the artistic side of glass and the industrial side of glass bottle making. Then we'll talk a little about cardinal glass. You finish up your crystallization lab and then do your glass observations. Don't see any burnt spots. But first, if you want to go back to your seats, we've got 2 videos that I've always shown for this lab that kind of give you some different perspectives. So thank you. Once again, we didn't end up eating it, but you never know.
Not really.
And interestingly, the ones that look copper will still have a characteristic color when you look through them. It's copper on top, but will still have a transmission color that's its characteristic color. So that's reflected versus transmitted color. So they can be quite different.
This looks like